All right, so we're using this graph for all of these first ones here. It didn't print with arrows on the ends. If that bothers you and you want to stick arrows on the edges of all of those, they are going to continue on. If that like just visually helps you. All right, so we're going to state x values where a limit does not exist. So we want x equals, and there are two of them. I'm sorry. Where does a limit not exist? At 3, there's not a limit. And then where else is there not a limit? -1. There is a limit at 4. If you zoom in on that point, both sides come to the same place. So there is a limit there. All right, number 2, state the x values where the limit exists, but function is not continuous. So which one is that? Where we have a limit, but the function's not continuous. That would be 4. And is that removable or non-removable? That's removable. So there is a limit, but we're not continuous. It's like, haha, tricked you, I stole the point, it's over here now. And then 3, where is the jump discontinuity? At x equals what? Yeah, -1 is where there's a jump. Good. And the rest of these we're just answering the questions. So limit as x goes to 4, what do you think? 1. This is like your quiz 2.0. It's like your quiz over again, these kind of questions. This is limit as x goes to -1 from the negative side, so from the left. So you want to look at -1, and remember you can cover up everything else, like just focus on -1, but we want to go just from the left. So that would be what? 3. Good. And then -1 from the right would be 1. I know there's a hole there, but it doesn't matter. A limit is behavior. And so if the left was 3 and the right was 1, what's the limit overall? DNE. You're like, I knew one of those was coming at some point. Now this one, we did do questions like this. Do you remember where we had to draw a graph? And I was like, do you see how it's approaching from above sea level or below sea level? They word it like this, okay? So we did do ones like this. We drew a little graph and I was like, is it coming from the above side or from the below side? But they're going to write it like this. So it says -1 from the left. Watch me point to this because I don't really have a better explanation than, hey, look. So here's -1. As you go from the left, what are you approaching? You're approaching 3 from above sea level or from below sea level? Do you see how it's 3 from below? Like if you drew a line at 3, you're coming at 3 from the below side, okay? So that's going to be limit as x goes to 3 from the negative side of the function. And so then we're going to evaluate it again. It's f of x. It's composite functions. It's like, usually it's f of g, and I say f got hungry and ate g. In this case, it's f of f. It's the same graph. But let me point to it again in case I lost anybody. As you go to -1 from the left, you're approaching 3, but from the underneath side. So it's 3 from the left. Are we all still on board? Okay. So then if we evaluate this again, we're going to go to 3 from the left side. Where's our graph headed? Negative infinity is your answer. And I think there's another one like that later on in this, so you'll see it again. All right, number 9, we're going to write a limit that is supported by the data in the table. So it would be limit as x approaches what? Like if you look at both sides of this, what x value is getting approached? 8. Do you guys see that there? Like on this side, it's 7.99999. Hope you feel better. And then on this side, it's 8.001. So like 8 is what we're approaching on both sides. Cool. Okay. Of the function equals, and where are both sides headed? Where are your f of x values headed? Yeah, 4. Good. Nice. Most of these translate to multiple choice questions. All right, using this information over here, find this limit. Do you remember when I shined up on the board, like all the limit properties? Like if you add, then add them. If you subtract, then subtract them. Do you remember that? That's this. That's how this shows up on it. So limit as x goes to 5 of f of x. Just look at the table. What is that value? Okay, so that part's 6. And then parenthesis. And then what is limit as x goes to 5 for h of x? 3. Like, don't overthink this, guys. It's right there. It's 3. Minus 4 times. And then for limit as x goes to 5 of g of x is -2. So like the math you're doing is just plugging those all in, and we're just going to see what we get. So 6 times, that would be 3 plus 8. So 11 times 6, so 66. So yeah, you're just using the table and plugging them all in. The way that they try to trick you is, in addition to all these limits, they'll give you f of 5 equals something or other and g of 5 equals something. Ignore those. You just want the limits. Does that make sense? Like, they'll give you more information than you need, and you have to just ignore them. All right, continuity. What needs to be true? Let's go through our rules. There's 3 of them. What's the first one? Has to have a point and a limit, and they have to agree. Yeah, connect. They have to agree. Okay. So at 4, so f of 4 needs to equal. Now it's the limit as x goes to 4, but they like to see you do from the left and from the right. So limit as x goes to 4 from the left of the function equals limit as x goes to 4 from the right of the function. Those things all need to be equal. The point and the limit need to agree. And the same thing needs to be approached from both sides. So that's what needs to be true for you to have continuity. Again, limits aren't necessarily hard. It's all the dang notation, how you have to write everything. Just remember, the math you actually do is not super difficult. All right, number 12. For this function to be continuous for everywhere, what needs to be the value for -3? Well, it's a fancy way of saying what's the limit as x goes to -3 of that. Now, if you plug in -3, because that's always your first thing, is just try and plug it in, what are you going to get? If you just plug in -3. 0 over 0. It's indeterminate. That means there is a hole. And that means you need to do, math, algebra, work, right? Until you get something. Okay, perfect. Until you get it to cancel. So what do we do with the numerator? Beautiful. X plus 3x minus 3. Cancel the x plus 3's. And the reason you always need to write limit is so you don't forget to what to do next. People that don't write limit, they'll stop there and go, what now? You have to take -3 and plug it back in. So your answer would be -6. -3 minus 3 will give you -6. All right, here we want the function to be continuous. That means you're going to take both pieces and set them equal to each other. Good. And then we're going to plug in 0. Okay. So you're going to set these equal to each other. Now there's a problem with this one. If you plug in 0, you're going to get 0 over 0. So we have to do a similar thing like what we did to here first. What can you do with this numerator? Yeah. Take out an x, you would be left with x plus 10. And then those x's are going to cancel. So now we can set them equal. So it would be x plus 10 equals x plus 2k. So you're setting the two things equal. We just had to cancel out the whole. And then, yes, we're going to plug in 0 for x. It's whatever number it splits at. And actually, it says it in the problem, too. It's going to say add x equals 0. So you're hopefully not going to miss that. But if you plug in 0 for x, you're going to get 10 equals 2k. And so k is 5. All right, here's our limits analytically. If you plug -1 into here, what are you going to get? Just do it mentally. Just try and plug in -1 and see what happens. 0. Okay, so we are going to have to do some canceling out. So write your limit. Always write that. And then we got to factor. So what is the numerator going to split into? Good, perfect. People tend to forget about 1, and I get that, but 1 times 1 is 1. And then on the denominator, it'll split. Perfect. X minus 7, X plus 1, or whatever order you wanted to write it in. But the X plus 1s are going to cancel. And then you have another step. Like, what do you still have to do? Yep. Plug in -1 to the x's. So that's going to make your numerator -2 and your denominator -8. So the negatives will cancel. And 1/4 is your answer. Cool. Are you hanging in there?
Yeah.
We haven't done anything exceedingly difficult yet, I don't think. And again, a lot of these translate to multiple choice. So 15, if you plug in 4, you're going to get 0/0. The way we handle it when there's a square root, we did do one in the notes. We'll just see if we can remember back to it. You multiply by the conjugate. So instead of square root of x minus 2, we're going to multiply by square root of x plus 2. And whatever you do to the numerator, you have to do to the denominator. So you have to do it to both of them. It looks awful right now, but the point of that is it will get things to cancel. And the reason why you have to do that is because square root of x times square root of x is what's going to give you like just x. Like that's how you get the roots to cancel out. So limit as x goes to 4. This numerator, if you start trying to distribute that all to each other, it's going to be totally awful. So I would kind of just leave that alone. You can split this though. What is that going to split into? Okay, you guys probably already all wrote it while I was up here talking. All right, and then square root of x plus 2. Just leave it alone. If you start to try to multiply that together, you're going to get like a big bucket of awful. And then hopefully go, hey, wait a second, this is not good. So if you multiply it in the denominator, square root of x times square root of x is x. That was kind of the whole point. -2 times 2 is -4. So what happens? It's kind of like, oh, those are gone. And then you still have one more step. You have to plug in 4. So 4 plus 4, 8. Square root of 4, 2. Plus 2 is 4. So the grand total answer 32. I'm getting 32.
Oh, I added them.
Oh, okay. It happens. I thought for a second I had messed up. 8 times 4 is 32, right?
No, it is.
Oh, okay.
My brain was just adding them because I did addition from it.
All right, this one looks really awful, but I promise it's not going to be too bad. We want limit as x goes to 5 for this mess to equal 7. So let's set up limit as x goes to 5. And we're going to try to factor what we can to get some stuff to cancel. So x minus 3, can't really do anything with that. What do you think about x squared minus b squared, though? It will be x plus b, x minus b. It's the same thing as x squared minus 16. It's just instead of an actual number, they put a b squared in there. So it's a difference of squares, just the letter instead of a number. All right, and then down here, we're going to split that first part. What's that going to factor into? Yep, it'll be 3 and 1. Yep, minus 3 plus 1. And then that x plus b is like kind of just there. So like it looked terrible, but some stuff should cancel. Actually, 2 things are going to cancel. What's going to go away? Yep, good. So those are all gone. Now don't forget what you're doing though. You now need to plug in 5 for x. So if you plug in 5 for x, that's going to give you 5 minus b and then over 6. Now we need to find b. So I'm going to set this equal to 7. Why is it 7? Because that's what it says in the problem. But I get 0 happens a lot. Everyone's like, I don't know what to do. Set it equal to 0. And that's not a bad guess. Like, don't get rid of that in your mind. There's a lot of times we set stuff equal to 0. So, but in this case, 7. All right. And then welcome back to algebra class. You would multiply by 6. So 5 minus b equals 42. subtract 5, so negative b equals 37. So b equals negative 37. So to recap that one, we factored, we canceled out. It was limit as x goes to 5, so we plugged in 5, and then we set that equal to 7, basically because they said so. All right, here's squeeze theorem. You have something smaller than something smaller than something else. The one in the middle is getting squeezed, okay? Do you remember how basic the math is, though? You do one side and you do the other side. If they're the same, that's, yeah, the middle one has to equal that. If they're different, you can't get an answer. Basically, you don't have enough information to get an answer. All right, so here's f of x, here's g of x. That's the small one and the big one. Find limit as x goes to 1 for h of x. So we're going to do limit as x goes to 1 for each of the others. And just basically, you're just seeing if it comes out the same or different. I'm writing limit to be super thorough, but if it's multiple choice, is anyone checking your work? No. So if you don't want to write it, you technically, unless it's free response, you're basically just plugging 1 into both of those and seeing if it comes out the same or different. So if you plug 1 into the first one, what do you get? -1. And if you plug 1 into the second one, oh my gosh, that means our answer is -1. If they came out different, you would do this answer, like we can't get an answer. We don't have enough information to answer the problem. Do they come out the same or do they come out different?
What do you write? Like, is there a specific thing you write?
So it will be multiple choice, but that's why I was kind of thorough with writing out the limits. If you had to write out some work, it would be this. You would show the limit as x goes to 1 for that one, limit as x goes to 1 for the other one.
If it doesn't equal each other.
Oh, you would just say, like, well, showing that shows that they're not, like, if this one came out to -1 and that came out to 4, that's sufficient work. Then you would just write, state that it cannot be found. You just like, it cannot be found. Yeah. All right, here we have your piecewise functions. Limit as x goes to 2 from the left. Here's the most common mistake. People will plug in 1, and I totally get why that happens. You're still plugging in 2. 2 is your number. The from the left or from the right tells you which piece of the function to plug into. So you're still plugging in 2, but from the left means which piece are you going to use? Yeah, like the less than 2, like this one. Okay, number smaller than 2. So if you plug in 2 for this one, what do you get? 0. Very good. 2 from the right, you're still plugging in 2. It's just telling you to use this piece of the function. So 1/4 times 2 be 2/4. So 1/2 minus 3. Yeah, -2.5. If you're a purist with the fractions, -5/2. But for this one, you don't really need to look at the function at all. If the left was 0 and the right was -2.5, what's this? Yeah, and visually, what would it look like? A jump. It would be a jump. All right, so let's look at another piecewise function. At what x values is the function discontinuous? You're going to have to check -1, you're going to have to check 3, and you're going to have to check 5, and just see if they link up. The math you're doing is just plugging numbers in though. So here we go. Let's test -1. If you plug -1 in here, what do you get?
Oh, wait, one that was
8. Let me write it out just to make sure I'm being thorough. So that equals 8. If you want to just do it in your head, that's fine. I just want to make sure we're all on the same page. If you plug -1 into this one, -1 plus 9, you get 8. So what that tells us is at -1, what did the two pieces do? They touched. So we're continuous there. We're good at -1. Are we all together? Okay. Now we're going to test 3. So we're going to plug 3 into this piece. 3 plus 9 is 12. If you plug 3 into this piece, 2 times 3, 6 plus 6 is 12. So what does that tell us is going on at 3? They meet. So we're good at 3. Now let's test 5. If you plug in 5 here, 5 times 2, 10 plus 6, 16. Now, I would say if you plug in 5 here, but you can't plug in 5 because it's constant, it's just -4. What does that tell us is going on at 5? And what would it look like? It would be a jump. Okay, so when it says at what x values is the function discontinuous, the only one is 5. So you test each of them and see where they don't link up. They either link up or they don't. All right, here we have our limits to infinity. If you have a horizontal asymptote, just visually think about that. These both sides are leveling off at -2. What must be true? It means your limit as x goes to infinity of the function equals -2. If you have a horizontal asymptote somewhere, it means your limit to infinity is going to level off there. Now, I threw this next section on here just to practice all of them. If you end up, I'm just going to write it off to the side here, with small over big, for lack of a better way of putting it, those are super technical terms there. Where is that going to level off? If the denominator keeps getting bigger and bigger and bigger and bigger and bigger. Good, because you end up with a situation where the denominator is getting bigger and bigger and bigger and bigger and bigger. And if I offered you 1/1,000,000th of a piece of cake, you'd be like, gee, thanks, because that's nothing. All right, if you have big over small, if the numerator keeps getting bigger and bigger and bigger and bigger, then it just keeps getting bigger and bigger and bigger. And so it's going to go to infinite, positive infinity. Okay, good. So I just want us to compare and contrast these. To recap, exponential grows faster than polynomial, grows faster than logarithmic. That's the order of like who beats who. Okay, or like who's in charge here. So limit as x goes to infinity, f over g. That puts ln over e. So you have ln over e. That's small over big, so 0. Now, if you flip that around, g over f, you have exponential over logarithmic. So if you have e to the x over ln of x. Big over small, so it's going to be positive infinity. Good. I did one of each type of way it could turn out, just so you could see them all. All right, f over h, that would be ln over x to the 5th. So that's a logarithmic over a polynomial. Small over big, that's 0. They're all 0 or infinity, guys. H over f, so that's x to the 5th, so a polynomial over a logarithmic. I just can't hear you. That one's infinity. Big over small, so infinity. And then the last two. So g over h, that would be exponential over polynomial. Big over small is infinity. H over g, so that's a polynomial over exponential. That's going to be this kind of situation. So 0.
So if we don't know, it's 0 or infinity.
All right, and then these ones, who's in charge for the numerator? 3x squared. Who's in charge for the denominator? Yeah, negative x squared. They're the same, so what do you use? Coefficients. So 3 over -1 is -3. And then this is really similar to that little section that we just did. I'm just checking if you remember about what number E is. E is about what? It's 2, well, I guess it would round to 2.8. It's 2.718. Anyway, it's bigger than 2. E is larger than 2. So you have small over big. So 0. I basically threw that on there to see if you remembered how much E was.